Hey everyone, and welcome. Ever wonder how this planet of ours actually works? I mean, really works. Today we're going to peel back the layers. Think of this as, I don't know, the ultimate user's guide to planet Earth. We're talking everything from a tiny microbe to a giant whale, so let's get right into it.
All right, to kick things off, I've got a question for you. What could possibly connect a mushroom, a tiger, and the sun? I know, it sounds like the beginning of a bad joke, right? But the answer is everything. It's the key to understanding how life on this planet is woven together in this incredible, interconnected system.
And that system, we call it an ecosystem. You can think of it as the giant stage where all the drama of life plays out. And honestly, it's the bedrock for everything we're going to talk about today. So what is an ecosystem, really? Let's break it down. Basically, it's any place where living things, plants, animals, interact with each other and with all the non-living stuff around them, things like rocks, water, sunlight. And the cool part is an ecosystem can be massive, like an entire ocean, or super small, like a little puddle in your backyard. Okay, so every single ecosystem is made up of two main parts. You've got your abiotic components. That's just a fancy word for all the non-living stuff. Think sunlight, soil, water. Then, on the other hand, you have the biotic components. And that's all the living players in the game. Plants, animals, fungi, you name it. You absolutely need both for the whole thing to work. All right, so let's get to know this biotic cast of characters a little better. See, in an ecosystem, every living thing has a job to do, a specific role to play, especially when it comes to how energy moves around. And we can basically split them into three big groups. First up, you've got the producers. These guys are the ultimate self-starters, the powerhouses of the whole system. We're talking about green plants, algae, anything that can take sunlight and, through photosynthesis, turn it into its own food. They don't need to go hunting for a meal. They make the meal. They're literally the foundation of all the energy in the ecosystem. Then you have the consumers. And, well, the name kind of gives it away, right? These are all the organisms that get their energy by eating other living things. They can't make their own food, so they're totally dependent on the producers to survive, whether they're eating them directly or eating something else that ate a producer. And consumers aren't all the same, of course. They come in a few flavors depending on their menu. You've got your herbivores, those are the plant eaters, like a deer. You've got your carnivores, the meat eaters, like a lion. And then there are the omnivores, who aren't picky, they eat both plants and animals. Sound familiar? Yep, that's us. And finally, we have a group that is absolutely critical, but often gets overlooked, the decomposers. Think of them as nature's ultimate cleanup and recycling crew. We're talking about fungi and bacteria. Their job is to break down all the dead stuff, plants, animals, and return all those precious nutrients back into the soil so the producers can use them all over again. They literally complete the circle of life. Okay, so we've met the main players, the producers, consumers, and decomposers. But how does it all fit together? Well, the number one rule of any ecosystem is all about the flow of energy. It really just boils down to one simple question: who eats whom? The easiest way to visualize this is with a simple food chain. Let's take a look. It all starts with the plants, our producer, soaking up energy from the sun. Then along comes a grasshopper. That's our primary consumer, and it munches on the plant. Next, a mouse, our secondary consumer, snacks on the grasshopper. And finally, an eagle, the tertiary consumer at the top, swoops down and grabs the mouse. See that? It's a straight line of energy transfer, from one level to the next. But nature is almost never that neat and tidy. Of course it isn't. That mouse, it might also get eaten by a snake, and that grasshopper could just as easily be eaten by a bird. In the real world, all these simple food chains are linked together in a big, messy, complicated food web. And it's just a perfect illustration of how everything, and I mean everything, depends on everything else. Okay, now here's something that is absolutely mind-blowing about this whole energy transfer thing. It is incredibly inefficient. There's something called the 10% law, and it's simple. Every time one thing eats another, only about 10% of the energy from that meal actually gets passed on. So where does the other 90% go? It's mostly lost as heat, just from the organism living its life. It's like nature charges a 90% energy tax at every single step up the chain. Let's put some numbers to this so you can really see it. Let's say our producers, the plants at the very bottom, start with 10,000 units of energy from the sun, okay? That's our starting point, 10,000. Now, when our primary consumer, that grasshopper, comes along and eats the plants,
it only gets 10% of that energy, so it's left with just 1,000 units. Boom, a 90% drop right off the bat, at the very first step. And it just keeps going. The mouse that eats the grasshopper, it only gets 10% of that energy, so now we're down to just 100 units. See what's happening? By the time you get to the top of the food chain, there's hardly any of that original energy left. And that right there is the key. It's why you almost never see a food chain that's longer than 4 or 5 links. There's just not enough energy left to support anything higher up. So you can see this is a really, really finely tuned system. But what happens when we throw a wrench in the works, when we introduce things that don't belong? Well, unfortunately, that's when things can go very, very wrong. One of the scariest problems is something called biomagnification. Here's how it works. You get a harmful substance, like a nasty pesticide or a heavy metal, that gets into the ecosystem. The problem is it doesn't break down. It's non-biodegradable. So instead of disappearing, it just builds up in the fatty tissues of the organisms that absorb it. And this is where we see this really dangerous reversal. Remember how energy goes down as you move up the food chain? Well, with these toxins, it's the complete opposite. Their concentration goes up dramatically. Because when a predator eats its prey, it's not just getting energy. It's also getting every bit of toxin that prey has accumulated over its entire life. This leads to super high, super dangerous levels of toxins in the animals at the top of the food web. And these disruptions don't always come from inside the food web. Sometimes the problem comes from way, way outside, but it affects everyone. The classic example is what happened with our ozone layer. We've got this natural shield in our atmosphere that protects everything on Earth from the sun's most harmful UV rays. But then we started releasing chemicals, CFCs, that were literally eating holes in it. More UV radiation gets through, and that doesn't just harm us. It can seriously damage the producers, the plants at the very foundation of pretty much every food web on the planet. Okay, so it's clear that these finely balanced systems are pretty vulnerable. And that brings us to the big question, right? What can we do about it? Well, a massive piece of the puzzle is all about managing our own stuff, specifically all the waste we generate every single day. Pretty much all the trash we make falls into one of two buckets. On one side, you have biodegradable stuff, food scraps, paper, things that nature's decomposers can actually break down. But on the other side, you have the non-biodegradable stuff. We're talking plastics, metals, glass. This stuff, it doesn't really go away. It can stick around for hundreds, even thousands of years, just clogging up the system. So what are our options for dealing with it? Well, there are a few main methods. For all that biodegradable waste, we can compost it, basically helping the decomposers turn it back into amazing fertilizer for the soil. For a lot of the other stuff, we use landfills, which are basically just giant holes in the ground. And yeah, they get the job done, but they take up a ton of space. Incineration, or burning waste, shrinks the volume way down. But probably the smartest option for a lot of our non-biodegradable waste is recycling. It takes something that would have been a problem and turns it into a resource we can use again. So there you have it. We've met the producers, the consumers, the decomposers. We've followed the energy as it flows and watched how toxins can build up. I think if there's one takeaway, it's that everything is connected in this unbelievably complex web of life. And if that's true, it means that every single choice we make, no matter how small it seems, sends ripples out into that web. So I'll just leave you with this thought. What will your ripples be?